Hi everyone. Today we'll see few more problems on DC transients. For the circuit shown in figure, find the current equation when the switch is opened at t is equal to 0. Earlier the switch is closed. This is RC circuit, RC parallel circuit. Earlier the switch is closed. Now we are opening the switch. Earlier when the switch is closed for the longer duration, switch is closed from minus infinity to till 0 minus, the switch is in closed state. At 0 the switch is open. From 0 to plus infinity also the switch is in open condition. So that's what it means. So when switch is open at t is equal to 0, the circuit diagram will become like this. Switch is open, 200, the same circuit diagram. 5 microfarad is connected in parallel with the 50 ohms. The current flowing through the capacitance or this loop is nothing but I. What you have to do as a first step, apply KVL to the loop which is having that energy storage elements. You apply KVL to this loop. When you apply KVL to this loop, 50 into I plus 1 by C, 1 by 5 into 10 power minus 6 integral of I into dt is equal to 0. By differentiating on both sides, you will get the 50 into di by dt. Differentiation of integral is nothing but only I by same C value, 5 into 10 power minus 6 is equal to 0. By rewriting this equation, by dividing on both sides with 50, you will get it as di by dt plus 1 by 50 into 5, 250 into 10 power minus 6 into I is equal to 0. This is your first step. As a second step, you have to this is your obtained differential equations. You have to compare this with the known differential equation. The second step is nothing but known differential equation, that is dx by dt plus px is equal to k. That is second differential equation. Known differential equation. Compare this first and second equation so that you will get x is equal to I, p is equal to 1 by 250 into 10 power minus 6, k is equal to 0. So it is the solution of this known differential equation. X of t is equal to e power minus pt integral k into e power plus pt into dt plus c into e power minus pt. For this, if you find out the solution, k is equal to 0. As k is equal to 0, this first term will become 0. Only have second term. That's why I of t is equal to c into e power minus p into t. P is equal to this I am substituting. So I'll get that minus t by 250 into 10 power minus 6. This is your third step, that is third equation. You got the solution of this current, but you have one arbitrary constant. To eliminate or to find out this arbitrary constant, you have to use the initial conditions. What are the initial conditions here? T is equal to 0 minus, that is past earlier state, t is equal to 0 and t is equal to 0 plus. At t is equal to 0, we are opening the switch. It will carry forward, right? It will be the same state. That means t is equal to 0 and 0 plus open state only. But t is equal to 0 means earlier the switch is in closed state. That's what I have written. T is equal to 0 minus, the switch is closed. For the capacitor, you need to find out what is the capacitance voltage that you have to find out, because capacitor do not allow the sudden change in voltage. When the switch is closed for longer time, from minus infinity to 0 minus till 0 minus, the switch is closed, the capacitor will act like a open circuit in steady state. This is nothing but longer time means that is steady state. In the steady state, the capacitor will act like a open circuit. In the same circuit diagram, I am opening the switch. This will act like a open circuit. When it is acting like a open circuit, this is the circuit diagram. So if you see, the plus is connected to the plus of the supply, minus is connected to the minus of the supply. Vc is equal to 200. Voltage across capacitance is equal to 200. Under transient, the capacitor will carry the same voltage. Do not allow the sudden change in voltage. That means, if you see, when the switch is open, even the switch is open, the capacitance voltage will be the same voltage. That is 200 volts and 200 volts only. What about the current when the switch is closed initially? As capacitance is open circuit, the current is nothing but 200 is divided by 50. 200 by 50. Voltage divided by resistance, that is equal to 4 amperes. So even when the switch is open also, the switch is open, the circuit diagram becomes like this, right? When the switch is open, The voltage across capacitance will be same, means it is again 200 volts. 200 volts by 50, 4 amperes only. Even the switch is open also, the current is 4 amperes and 4 amperes. So I'll use these initial conditions, t is equal 0 plus, and I'll substitute in the third equation. If I substitute t is equal 0 plus in the third equation, I of 0 plus is equal c into e power t, that is equal 0 plus e power 0 is nothing but 1. So what is I of 0 plus? 4 ampere. So loop current, that is. So 4 is equal c, that is equal c is equal 4. This c is equal 4, I'll substitute in the third equation to get the final solution, current solution, as I is equal 4 into e power minus t by 250 into 10 power minus 6. This is all about the problem. Thank you all.